everyone, today we are going to boil water with ice. So I have some water in this Florence flask and I'm going to heat it up so that I can get it to boil. Remember, boiling is when the vapor pressure is equal to the external pressure. So if you look at my flask here, here's my H2O liquid. In any liquid, some of the particles are moving fast, some are slow, some are kind of in the middle. The ones that are moving fast, if they get close to the surface, they escape and they become gas. So you have some water vapor right at the surface of the liquid here. And that water vapor, because it's a gas, they collide together, cause pressure, and that's what we call vapor pressure. The particles in the room, the air, those are gas particles as well, so they're colliding together, and these are causing the external pressure. Boiling happens when the vapor pressure is equal to the external pressure. So initially, my vapor pressure was low compared to the external pressure, so I have to heat it up so that I increase my vapor pressure to match my external pressure, and that's when it's going to boil. And I increase my vapor pressure by heating it, because heating it will make the particles go faster, so more of these liquid particles would turn into gas, and those gas particles collide more to make my vapor pressure equal to the external pressure. I know that it's boiling because I see bubbles. So what's inside of these bubbles? Well, obviously it's a gas. So maybe some of you might think it's air, or might think it's hydrogen or oxygen from the water, or maybe water vapor. So let's go through these. Well, it can't be air because if you notice, the gas particles are coming from the bottom and going up. If it was air, they'd start at the top. So it can't be air. It also can't be oxygen or hydrogen, because if I had hydrogen in there, it would explode. Hydrogen is extremely flammable and explosive. And also, boiling water, this is not a chemical reaction. I can't turn H2O into H2NO2 just by boiling it. So what's inside of the bubbles is H2O gas. It's water vapor. So I'm going to go ahead and, now that my vapor pressure is equal to the external pressure, I'm going to stopper my flask. I have a stopper that has a thermometer through it. So I'm going to stopper my gas and take it off the heat. And I'm going to flip it upside down so you can just see it better. And right now you see that it's not boiling anymore. Well, why is it not boiling anymore? Well, because when I took it off the heat, my vapor pressure decreased again. It's not equal to the external pressure anymore. My vapor pressure went down because it's not being heated anymore. So what I'm going to do next is I'm going to put some ice on top right here. And you see that it starts boiling. So we are actually boiling this water by applying ice to it. So how is that working? Well, let's think about this. Boiling will happen when the vapor pressure and the external pressure are equal to each other. Normally, the external pressure is higher than the vapor pressure, so one of two things. I either have to heat my liquid so that my vapor pressure rises up and matches the external pressure, or another option is I can lower my external pressure and make it match to the vapor pressure. So let's draw a diagram of what's happening here. So I have my flask upside down, and it's stoppered. Here's my liquid level. And so some of these particles are in the liquid that are moving fast enough are able to escape and become gas, and that is what's causing the vapor pressure. Well, where's my external pressure? My external pressure is because of the particles, the gas particles that are right here, right? It's not open to the room, to the atmosphere, so my external pressure is caused by these gas particles that are at the top here. And so what I did was I put some ice cubes right here, and when I put ice cubes here, these particles slow down, they don't collide as much, and so I drop my external pressure enough that it matches the vapor pressure, and then it boils. So you can get it to boil at a lower temperature by applying ice to it, because we are lowering the external pressure to match our vapor pressure. So I would like you to watch a video by Julius Sumner Miller. He is an awesome physicist. He did this demo, except he's much cooler than me. All he did was he just touched it and it boiled, as opposed to me putting ice there. But he also does a very other cool demo where he freezes water by boiling it. So let me explain what he does to you before you watch it. So what he does is he takes a watch glass and he puts a little bit of water in there, and he puts this in a bell jar and connects it to a vacuum pump. And initially, so there are gas particles here on top of the liquid, that's your vapor pressure. There are air particles here causing your external pressure. And so initially, the water is not boiling because the external pressure is higher than the vapor pressure. So what he does is he connects this to a vacuum pump. A vacuum pump removes some of these gas particles. And so now that you have less gas particles, your external pressure is getting smaller and smaller and smaller, until the external pressure matches the vapor pressure, and he actually gets this water to boil. But what happens is, because he's getting it to boil without applying heat to it, all the fast-moving particles here are escaping and turning into gaseous particles, and we're removing them with the pump, that because evaporation is a cooling process, so the hot, fast particles leave, and all you have in here are the cold particles. It gets colder and colder and colder. The liquid gets colder and colder and colder until it reaches its freezing point and it freezes. Very, very cool. So I highly recommend that you watch that video. And before you go, let's see if we can get this to boil again with applying more ice to it. Yep, it is boiling. And my thermometer says that it is right now at 70 degrees Celsius compared to the normal boiling point, which is 100 degrees Celsius. Thanks, guys. Have a great day. Bye.